Alright, so what we're going to do in this video is prove that for every a and b in F, or every pair of scalars a and b in a field F, and for every x in Fn, where Fn is the set of all lists of length n of uh, Fn is the set of all lists of length n, where each of the elements in a list is well, a scalar or a member of the field F. So in other words, this is Fn. Fn is equal to the set of all lists of this form, where each x1 and xn is an F. So yeah, that is Fn, and we want to show that really we can think of this as showing that scalar multiplication is associative on Fn. So we want to show that a times bx. So the scalar a multiplied by the vector bx is equal to the scalar ab multiplied by the vector x. So let's prove that. So by the way, before we prove that, how do we define scalar multiplication of of a member of a field with a member of Fn? How do we define what lambda x is going to be? Well, clearly we can write x, so we can say that there exist n scalars. Sorry, not in Fn, in F, such that x can be written as a list of these x elements. Sorry, x can be written as a list of these n elements, x1 through xn. And so we say lambda x is defined to be equal to the list with coordinates lambda x1 through lambda xn. So essentially each of the coordinates gets multiplied by lambda. And x1 through xn here are field members, so obviously lambda is a scalar, x1 and x2, x3 all the way up till xn are scalars. So if you multiply two scalars, you get another scalar, because clearly well, multiplication is an operation which is obviously closed on fields. So yeah, okay. We're going to now start with the proof. Let's say this is, we're going to say, suppose A and B are members of field F and X is a member of field N. Then again the same thing that we did in our scratch work. There exist n scalars x1 through xn such that x can be written as a list of x1 through xn. Now we have, let's start with the left hand side. We have a times bx is equal to a times b times x1 through xn. This is equal to a times bx1 through bxn. This is equal to well, again this is going to be equal to a times bx1 up till a times bxn. If that was a bit, if I rushed through that a bit too much, so what I'm trying to do here is I rewrote x in this form as a list of n elements, and we use the definition of scalar multiplication that we have defined for scalar multiplication by scalar multiplication of a member of a field with a member of Fn. So we use that, the one that we defined, and then we have this list right over here. And now we're going to multiply, we're going to, again, A is a scalar and bx1 through bxn is a list. And we're going to, again, multiply A by each coordinate of this list, and that is going to become our corresponding new coordinate for the new list. So we have a times bx1 up till a times bxn. So x1 through xn are scalars, and a and b are obviously scalars. So all of this makes sense. Because they are scalars, we can use associativity of multiplication on a field, and we get this thing. We can change the order of multiplication, and you can probably see where I'm going with this. And we can now take out the ab quite nicely. Say that this is equal to the scalar ab times the list x1 through xn, which is really equal to a b times x, and that is what was exactly what was desired. So we can just check that was what was desired. So we want to show that a times bx is equal to ab times x, and that is what we achieved. And so that is the end of the proof.